Hello and welcome. We are looking at basic constructions. Now this is geometry, of course, and in terms of these constructions, we are actually going to make a few things listed down here. I'll get to that in a moment. In order to do that, we're going to use something called a compass. Not the kind of compass where you look at directions north, south, east, and west. This is an actual geometric tool that's designed to draw a circle or an arc or arcs based on a preset radius. So I will be using this one right here. This is actually a part of my software. The ones that you'll normally see, an actual physical one looks like this. It has something that you can change the width of right here based on this. You have a pencil or something at the end where you can actually mark, and then right here is called a pivot, or at least that's what I'm calling it. I believe it's what it's called. So when I use some of these other, in the later slides I use the word pivot. That's what I'm referring to. It's kind of a needle, so that way it stays in place, and then you can twirl this part around and you can actually create a circle based on it. So when I use this tool right here, if I use it with this pivot, like I can shrink it, I can rotate it, etc. If I enlarge it a little bit, I can use the pencil and actually draw circles with it, which is actually very nice, perfect circles. Or I can draw little segments called arcs, which I'll be doing a lot. When you use a straight edge, like a ruler or anything else with it, you can then begin to do some other things with this, because we're going to be doing a lot of things with straight lines as well, and the compass is just going to help out with that. So you can construct congruent segments, congruent angles, perpendicular bisectors, and angle bisectors, and we'll be doing all four of those. Let's start with congruent segments. These are the steps in order to make it happen. I might go through them step by step, but I'm also going to be leading with it down here. Let's say you have a segment AB, and you want to use a compass to create another segment that is the same length as AB, like CD, and I'm also going to do it another way, EF. With the segment you wish to duplicate, meaning AB, open your compass to the width of the entire segment and maintain this width. So what I'm going to do is I'm going to take the compass, take the pivot of the compass right there alongside A. I'll be as accurate as I can possibly be. And I'm going to stretch this compass out so that it's the entire width of it. So that length AB, like so. Okay? Now I'm going to create a new point and place the pivot on that point. So this new point C is newly created. You can mark that with a pencil. And then boom, I'll take my pivot right to that point C. With the pencil end being the same width apart as the original segment as it is, sketch a small arc to indicate your ending point's distance from your original point. So what you might do, you can probably do a little point, but depending on your compass, it might be harder to do. You might just draw a little, a little arc like that. I can do a big one. I could do like that, but that's kind of a waste of space there. You don't need all that. Just a little bit, because you might not go straight on. And then use a straight edge to draw a line segment from point to point. So from this point to any point on your arc, it doesn't matter which one, I'll try and go as straight as possible here, I'm going to create a line segment like so. And then erase any remaining pencil marks that were derived from the arc. So for instance, if there's a little point on C or whatever else, I'll take that and I'll take this and I'll erase that as well. And I'll move the compass out of the way, and voila! I have made, let's go and write in another letter, I have made a new arc called CD. I'm calling it CD. There's my other point. And it should be the same length as AB. So statement I could write alongside that is I made AB, segment AB congruent to segment CD. And that was the point, to make congruent segments. Alternatively, what you could do is you could draw a segment very long to begin with. Okay, like this segment starting at E, and it could end somewhere. And what you're going to do now is take that compass right here, make sure it's that width that you wanted it to be at, okay, matching up just like that, bring it down here, and then draw that arc. Now as I draw the arc, now I know where I want my cutoff to be. So when it comes to me doing this, what I'm going to do is I'm just going to shrink it, okay, because I'm on computer software. So if I shrink it to that length right there, or anywhere up there or down there, remember it's going in a circular fashion, so the radius is the length, then boom, I take that off, and it should be near congruent, if not exactly. And there we go. There's a new segment, also EF, which too is congruent to these other segments. So there's F, like so. Okay, and I've made two duplicates of what I wanted to. So AB is congruent to CD. It's also congruent to segment EF. Okay, let's look at congruent angles. This one has a few more steps that are just a little more difficult to follow, but go ahead and try and follow along here. So here we have an angle. Now, it doesn't necessarily matter how long this thing is. You want some length into it, though. I'll show you why in a moment. You're going to want to draw an arc here. So with the angle you wish to duplicate, open your compass smaller than the length of either side, but still plenty large. So what I mean by that is I'm going to take this compass here, place the pivot on the vertex, okay, and then I'm going to start opening this wide. Now if I draw it too wide, then that's a problem because now I don't have anywhere to refer to. I need to basically have a point of intersection. So pretty wide, something like that. You want it wide enough. Step 2, placing the pivot on the vertex, like so. Draw an arc that crosses through both sides. By sides, I mean the sides of the actual angle right here. So vertex, both sides, and I drew an arc that actually crossed through both of them. Repeat this on your new segment, which you are attempting to duplicate the angle, placing your pivot on one end point. So here I have another segment. I want to take the pivot on one of the endpoints like so, and I want to repeat this step. Now I don't yet have the other side, obviously. What I want to do is actually draw that. So I'm going to start by doing this. So I need to draw at least far enough that I know that the side which I will eventually duplicate will be going through this point of intersection. So far I've drawn those two things. They were the same width. Okay? Now, adjust your compass so that it is the same width as the points of intersection with your sides and your arc. Okay, so points D and E, they're not yet made. Let's go ahead and just write them in. Let's make point D this guy here and point E this guy, the points of intersection. What I now want to do with my compass is place this so that the pivot, if you're looking right here, the pivot is on one end of a point of intersection with a segment, with a side and an arc, and I want to line this up so that this mark right here is also on the other point of intersection. It's a little tough because I have very little screen to work with. So kind of like that right there. You can kind of see what I did. So I need that to be on the other end. Okay? Because now what I'm going to do is I'm going to draw another arc about right there. That's about as perfect as I can make it for now. Okay, so that arc represents the point of intersection that is between that is for this right here and then the arc itself. So like I said, I could probably get that a little closer next time. The point is how we're doing it. So now going over here, I'm going to do the same thing. I'm going to take my compass, place the pivot right down there on that point of intersection. And then I'm going to go ahead and draw this arc with the same width, because now what I've created was that point of intersection right here that's supposed to be the same. And now what I'm going to do is take my straight edge, I don't have a straight edge, but take my straight tool, okay, and I'm going to draw a line segment from the vertex to the point of intersection between my two arcs. So if I want it as good as what the other one looks like, what I'd do is I'd put it just a little underneath, just like this other one is. You know, put it about right there to make it exactly kind of like the other one. And then I could also give another letter to this as well. Let's call it H. Okay, and then erase any other marks such as those arc marks. So hopefully, if I was as good as advertised, what I did was created a very close enough, if not exactly accurate, congruent segment. So if I take this segment, let's give it a different color so you can clearly see what we're looking at. If I take it and drag it up, very, very close, right? I was trying to figure out the whole thing with the arcs, but that's the idea of that congruent segment. So getting those points of intersection from those arcs. Okay, before we move on to the final two, I need to give you some definitions here. Perpendicular lines are two lines that intersect to form right angles. So if you look at these two here, I have line AB intersecting with line CD. And what we're going to say here is that line AB is perpendicular to, here's the symbol, it looks like the perpendicular shape, line CD. Okay, so that's what that means. A perpendicular bisector is where a segment, now it has to be a segment to be bisected, but a segment gets a perpendicular line, ray, or segment drawn through it, so perpendicular, right angle, and it divides essentially the segment into two congruent segments. So right here, let me add another point. Let's call it E, right in the middle. This new point is the point of intersection between AB and CD. CD is a line that was drawn through. It made this perpendicular, and it bisected it. So what it now allowed to do was, first of all, AB, line AB is perpendicular to line CD, again. And as CD bisected AB, it created a new point E that made segment AE congruent to segment EB. So perpendicular bisector divides it right in half, assuming it's a segment and it's perpendicular. An angle bisector is where you have some angle, like angle CAB right here, and then this ray AD is drawn through there, and it bisects angle CAB. And what that allows is it creates two congruent coplanar angles. As the angle is already on one plane, it now keeps it on the plane. So that allows angle CAD to be congruent to angle DAB. So now that we know those terms, let's go ahead and move on. Perpendicular bisector. Okay, with the segment you wish to perpendicularly bisect, let's begin with the pivot on an endpoint and widen the compass reasonably past the segment's midpoint. So what I want to do is widen this well enough that I'm past, like this might be about midpoint. I want to go past it. There we go, about right there. Let's take that and let's draw an arc above and below the segment enough so that the arc also passes the segment's midpoint above and below. So what that means is draw this arc low enough and high enough that I've at least gone past like the midpoint, because I'm going to create a point of intersection up here and down here, and I need it drawn far enough. Okay? Repeat this with the pivot on the other endpoint. Now, I did not mention that it should be the same width. So what I'm going to do is flip this over. I'm going to move this over, place it on the endpoint, keep the same width, and draw, keep the same width, and draw this arc up and down like that. Okay? What I've now created are two intersecting arcs on top and bottom. What this did is these are directly above and below the midpoint, and they go straight up and down. So what I'm going to do is use a straight edge to draw a line segment from the intersection points of both arcs above and below the segment. So if I start right here and I go straight down, right there, I have now created a perpendicular bisector after I erase this and this. This can be a line, this can be a ray, or this can be a segment, but this has now allowed for, let's call it CD. This has now created a perpendicular angle, and if I call this point E, that allows for AE, once again, to be congruent to EB right here. Okay, so it's right down the middle based on that. And the last one, angle bisector, kind of like the congruent angle one. It takes a little bit more practice to do here. With the angle you wish to bisect, so angle CAB, let's open our compass smaller than the length of either side, but still plenty large. So just like last time with the angles, let's bring it down to the vertex, widen it out enough, not farther than the sides. I'll do a little closer this time. I don't know if it's closer than last time, and then draw the arc, the same one we did last time, that crosses through both sides. So boom. Now what we're going to do is place the pivot on either arc segment intersection. So basically, if I place the pivot right there, that's on one of the arc intersections. And what I'm going to do, now I'm going to change the width because I'm going to kind of run out of room. I'm going to shrink it a little bit. What I now need to do is draw an arc, a new arc that's still inside the angle, like not outside of it, but inside this angle, but it's outside of the arc that the pivot's on. So it needs to be out in this area somewhere. And I'm going to draw one so that it's crossing through where an angle bisector would go. So say an angle bisector goes down the middle, I need to make sure that my drawing, my new one, at least crosses that area. So if an angle bisector goes through, it should probably be crossing there somewhere. I'm going to repeat this with the same width. I think this number gives me my width. See that? So I need it to be at 58. I'm going to repeat this on this side down here. So I'm going to flip it. I'm going to place the pivot right here, and keeping this compass width, repeat it. Draw it until the two arcs cross. So I'm going to go over here. I'm just going to go ahead and start drawing. Draw it. There we go, and it crosses with that arc. I was close to not being right there. So I drew it so these two arcs crossed. So I can start erasing, let's say, this arc right here. I no longer need it. Now what I need to do is use a straight edge to draw a ray from the vertex to the point of intersection between my two arcs. So I'm going to go ahead and take this, starting from the vertex. I'm going to draw a ray that goes outward, and it crosses through those two arcs right there. That ends up allowing for your two angles here to be congruent if all is well, if it's done correctly. Let's call that point D, just like I think it was before. And as ray AD bisects angle CAB, you have now created this statement that angle CAD is congruent to angle DAB. And I will mark that using blue. And I will say that this angle is now congruent to this angle. Especially, if I did it right, if it was very perfect. You can try and, I'm tilting my head right now, tilt it down to the side and go, oh yeah, it looks like that does divide those evenly. And erase anything else that's there, and we're good to go. Fiend.